please confirm if you can see my screen?
Yes, we can.
Yes, we
Yeah,
can.
we can.
Yes, we can.
Right. Thank you.
Maybe.
Another thing, when I flip my laptop, I won't be able to see those who trying to log in as guests. Please do let them in. And another thing, okay, for those who are logging in as guests, please make sure that you logged in using your UNISA details, right? Because I won't be able to see if like we are at the lobby. And again, no one is working doing that. It's no one's responsibility. Okay. Where are we? Did I just delete that? Okay, I'm getting it. I have so many things open. All right. Okay, guys, just a second. I need to close some of the things. That's the reason why I can't see. Please bear with me just a minute. Save. Okay. Then move. Still I can't see. Okay. Now it's fine. All right, guys, today's session is differentiation theory. Okay. The reason we need to learn differentiation theory is because derivatives are used to analyze the change in variables, quantities such as cost, revenue, and profits, and that helps it helps in making decisions in a business, in any business. I suppose some of you are working for companies, so this chapter is good for you. And another thing, guys, please make sure that you stop me if you don't understand. If you think I'm moving too fast, please make sure you stop me, because this chapter is very important. Like if I lose you here, that means you won't be understanding the rest of the session remaining in this course. The next chapter is the application of this chapter. Then the chapter after that, it's the antiderivative, it's the inverse of this chapter, then the application of that inverse. So yeah, just make sure you stop me anytime when you feel like I'm moving too fast or I'm losing you. Okay, after this class, you should be able to explain the concepts of differentiation and the rules of differentiation. I think I'll end there today. Okay, we'll start from the slope of the curve. Okay, here, suppose you are given y. Like suppose you have y. Please accept that one. And y is the quantity that depends on another quantity, saying y depends on x, like y is the quantity that depends on x, right? So y is any function of x, and we can write this as y equals y of x or equals f of x, okay? We have y, and y depends on x, meaning y is the quantity that depend on x, right? So if x changes, this value of x changes from x from x1 to x2, right? If x changes from x1 to x2, then the change in x sometimes is called the increment of x. The change in x, you'll write that as the change in x equals x2 minus x1. This is just the difference between these 2 points. Remember, I said x changes from x1 to x2. So the change in x is just the difference between x1 and x2. That's why we have x2 minus x1, right? Remember, y, we said y is a quantity that depends on x, right? And we are told that x changes from x1 to x2, right? Since y is a function of x, then that means we need to find the corresponding change in y. dy equals to, remember, we said y is equal to, we can write y as y of x or f of x, right? Then to find the corresponding change in y, we'll have change in y equals f of x2 minus f of x1, right? Because we said y is equal to, okay, y is equal to f of x. Now we have two y's, right? We have two x1 and x2. To find the corresponding value of x1 and x2, okay, you'll go to f or to y. Where there is x, you substitute x2 with, where there is x2 here, okay, you'll just okay, we had f at x. So where there is x, you substitute x with x2. And again, to find the corresponding value of y, where x is equal to x1, you'll go back here and y, where there is x, you substitute x with x1. So that's why the change in y is equal to f of x2 minus f of x1, right? And then we have the difference quotient, right? Which is the change in y over the change in x. Change in y over the change in x, okay? We said the change in y, or the change in y is equal to f of x2 minus f of x1, right? Over the change in x. We said the change in x is x2 minus x1, right? And we know this formula from the previous chapters, right? Which is y2 minus y1 over x2 minus x1. We said that formula is for calculating the slope. right? Okay. From the previous chapters, we said this formula is for calculating a slope. And a slope, sometimes it's called the average rate of change of y with respect to x over, okay, here it would be over the interval x1, x2, right? And this is just the slope of y. Again, a new term. Sometimes a slope is called a derivative of a function, right? So if the slope, okay, we said this is the slope of y, right, is equal to, let me write y2 minus y1 over x2 minus x1. And we said this sometimes is called the derivative. Okay, I'm not going to stick so much here on the slope session because you've done this chapter already. Okay, I was just introducing the derivative, right? The derivative of a function. Just know, sometimes you'll be asked to find the slope. You'll know that is a derivative. Or if they ask you to find the derivative of a line, just know they're asking for a slope of that line. Okay. Okay, we have different notation for the derivative. Okay. Usually we use y equal to, okay, let's say we are given a function y equals f of x, okay? To indicate that the independent variable x and the dependent variable of y, then some common alternative notation for derivative, we can write them as follows, okay? We have this as the independent variable and the dependent variable. If we have this and we are asked to find the derivatives, we can use this notation, f prime. Some books write the derivative notation as f prime of x. Okay, if your x is the dependent variable, or is the independent variable, and y is the dependent variable, then the derivative of this function, you can write that as f prime of x. Or again, you can use f prime. Or you can use, some books use dy over dx. Again, this is the same thing as df over dx. Again, you can write d over dx of f at x. Or you can write this as d f at x. Again, some books use this notation, dx f of x. Okay, this is just the derivative. So if you use, like, you find something on the internet, they use this for derivative, it's correct. Or you read a book, they use this notation, it's still correct. They are all the notation for derivatives, right? Okay, again, the symbol d, this d, or this dx, d over dx, these symbols are called the derivation operation, right? Because they indicate the operation of the differentiation. which is just the process of calculating the derivative.
Excuse me, ma'am. Sorry. What function are they called?
They called the differentiation operators. Okay. We have differentiation rules that allows us to differentiate different functions. Okay. Let's start with the simple function. The constant function. Okay, suppose you are given f at x, don't my pen. F at x equals to c, and you are told that c is any constant, right? Remember, I said the derivative is the same thing as the slope of the curve or of a function, right? If we write this, we plot this function, we'll have something like this. Let's say we have c here. Okay, this is 0, and these are the x-axis, and yeah, this represents y or f at x. These are the y-axis, these are the x-axis, and we have a function like this. This line represents this graph. Okay, c can be any constant, right? Okay, if let's say you are asked to find the slope for this function, okay, let's say we take 2 points. We have, say here we have x equals 1 and x equals 2. To find the slope of this function, you'll have slope equals to, okay, I'll say y2. I'll write this as y2. Okay, y. Or you can write f of x2 minus y1 over x2 minus x1. Okay, this is x1, this is x2. This is the formula for finding a slope. Okay, let's find the corresponding values of x equals 1 and x equals 2. If we substitute 1 here, we have c, right? If we substitute 1 where there is x here, since it's just we have a constant, just a constant. So that means if we substitute 1 where there is x, we'll have that constant. If we substitute here 100 where there is x, we'll have that constant again. Okay, so I'll write this as c minus, okay, we have, okay, this was, we substitute 2, we have c. If we substitute 1 again, we said we have c, right? So we'll have c over x2, our x2 is 2, and x1 is 1. So we have c minus c is 0, and we have 2 minus 1 is 1, and 0 divided by 1, this is 1, right? So this means the slope of this function is equal to 0, right? And remember, we said the slope is the same thing as the gradient, as the derivative, right? So from here, we can conclude that f prime of x or y prime or df over dx is equal to 0.
Hello?
Yes? Yes?
I'm lost on the where you said 0 divided by 1 is what?
Is 0.
Okay, so it's 0. Okay, thank you.
No problem. So this means, okay, the slope of a function, of a constant function, will always be 0, right? And we said a slope is the derivative, right? So this means from here, we can conclude that the derivative of a constant is 0. Okay, so that would be our rule 1. Okay, I will write the derivative as d over dx. Remember, I said we can write this, you can use this notation again to represent the derivative. Okay, so this is our rule 1. It says the derivative of a constant is 0, right? So, for example, let's say you are given maybe f of x equals 10, and you are asked to find f prime of x, meaning you are asked to find the derivative of this function. Okay, you can just go to, we can just use rule 1. You know that the derivative of a constant is 0, right, from rule 1. So you can just simply say this is 0. Again, you are given f at x, you are asked to find the derivative of hundreds. Hundreds is also a constant. Can just again say f prime of x is 0. Okay, that is our rule 1. Do we have questions before we move on to another rule?
Okay, hello. Yes, ma'am, I have a question.
Yes.
Can you please scroll up before the example?
Yeah.
Yes, up again. Okay, yes. Where you say f of x equals to y1, yes, y equals to dy divided by dx equals to df of
Yeah.
no.
Oh,
Yes, here. Yes, okay.
yeah. Okay.
Up again.
Up.
Yes,
Yeah.
yes, here. Yes. Where you said, what did you say? Both the you said are the differentiation operators, something like that.
Differentiation operators.
Yes. So I want to know that at the end of this function here, it's d over dx. Is it equals to fx, or that fx is next to?
You mean this part?
Yes, I want to know that is there a multiplication sign, or it's equal sign, or it's like that.
It's like this. Okay.
So the
You
f of,
see, it's
f of
like
x substituted by c, right?
it's like you have something like this, 2x over, let's say, over 100. Here, this is the same thing as 2 over 100 times x, right? So it's like, okay, you have this as your f at x. Okay, first you have df over dx. This is the same thing, right? This is your
Yes.
f. This is okay. This is your df dx, right? Then now I take this x, I multiply it with everything. So I have 2 over 100x. Okay, you'll get the same thing as someone who wrote it like this, or if you choose to write it like this. So let's come back here. We have df over dx. Then I choose to take this one and multiply with everything. That's why I have d over dx times f at x. It's still the same thing as df over dx. It's just that, okay, you read it differently. You'll say d over dx of f at x, right? But here you say df over dx, but it's still the same operation.
So it's given.
Pardon? Yes.
Is it given?
Yes. It's okay. Not really that is given. It's okay. The reason I wrote all this notation, I was saying if maybe you read a different book where they use this notation, it's still the same notation as this one or as this one. It's not different. They're still asking for the same thing.
Oh.
Can I ask a question as well?
You said you have a question?
Yes. Can you hear me?
All right. Yes.
Okay. Just on my side, I always find it confusing. Maybe I'm just gonna bring it back now. Where
I can't hear you.
can you not hear me? Can you hear me now?
No?
Hi, can you hear me?
Okay. Is it just me or okay, now I can hear you.
I think other people can hear me. Okay. I'm saying I always find it confusing for me when it says y is equal to fx. Like I don't understand this fx thing. Maybe I'm too slow, I don't know, but I don't understand the fx and what it means that y equals to fx. So I just get lost there.
Okay.
Maybe if you can simplify that, y fx and then just
Okay, I'm writing fx because sometimes you'll find the function written as f at x is equal to then that function. There is no need to write both as in y is equal to fx. There is no need. I'm only writing both of them because sometimes you'll find a function written as f at x, right? Then sometimes you'll find the function written y is equal to that function, or sometimes you'll find it written as y of x is equal to, it means nothing. It's just the way the function is represented.
Yeah, okay. It just throws me off, but yeah, no, I think I'll get it.
Can I try to explain it? Sorry.
Please.
Yes.
Hello, ma'am.
Yes. Are you saying something?
I think she muted the mic.
The speaker needs to mute their mic.
Okay, you can continue, Ms. Ngoma.
All right, thank you.
All right, or I can also maybe help with that. It's quite straightforward. Sorry to come in like that. So basically, when you see, especially when we on this particular topic, differentiation or derivatives. So when we are given a function to solve, when you see if it's saying f of x, it's basically y is equals to that particular equation. So when you see f of x, you must just think y.
Mm-hmm.
That's how I can put it. I don't know if it makes sense.
Okay. So x has no other function. It's just y has this different f of x function next to it. Otherwise, x is just x, nothing else.
Yeah. As far as I understand it, that f of x represents y.
Y. Okay.
Yeah.
Can I also try normally on the vertical axis, which is the y, that's where you find the
FX.
independent variable. So it's whatever is on y, it's always dependent on a horizontal, which is the x. Hence the function of x.
Okay. So x is the independent
Correct. X is the independent function.
function. Oh, so whatever is on y is dependent on x, hence f of x.
That is correct.
Thank you, sir.
Okay, can we move on? Thank you for those who assisted. I appreciate it. Okay, guys, let's move on to rule 2. Okay, rule 2 says if n is any real number, okay. If n is any real number, then the derivative of would be n x n to the power n minus 1, right? So this simply means you take n, you multiply with everything, right? Then you subtract 1 from that power n, right? N is your power and x is your base, right? You take n, you multiply with your base, and then you subtract 1 from n. Okay, let's do an example. Suppose we are given x10, and you are asked to find the derivative of this function, right? You see, remember in rule 1, we're differentiating a constant. So this means we cannot use rule 1 in a function like this, right? Let's try rule 2. Okay. You see, if you compare these two functions, this means your n is equal to 10, right? So if we use this rule here on this function, you will have, okay, where there is n, you will write 10. So this means your d over dx of x to the power 10 is equal to, where there is n, you write 10. You'll have 10 x to the power 10 minus 1, right? Because we have n here. And then you simplify further. If you simplify this would be 10 x to the power 9. And this is your derivative if you are given your function as x to the power 10. Again, let's do another one. Say you are given y equals x to the power 100, right? If you compare this x to the power 100 and this function, you can conclude from here that your n is now 100, right? And you know that the derivative of x to the power n is equal to n times x to the power n minus 1. So you can take that function and come back here. Where there is n, you substitute n with your 100, right? So this means our derivative, which is dx of x to the power 100 is equal to 100 x to the power 100 minus 1. And then you simplify, you'll have 800 x to the power 99. Do we have question here? Or we can move on?
Yes, I do have.
Yes.
Can you make an example of your function of x being 2x to the power 5 maybe, so that I can see the number that x is multiplied with? What do we do with that number?
You mean which function?
Can we have y is equal to 2x to the power 5, and then let's try and solve that one. I just want to see what will happen to that 2 that is before that x.
Okay, that will be our next rule.
Oh, okay, all right.
Yes, coming there.
Okay.
All right, do we have any question beside that one? Okay, in your spare time, please try this.
Sorry, ma'am.
Yes.
I don't know if this is a stupid question, but what if
There's no stupid question.
what if the power number is negative?
Okay. You still apply the same rule. Remember, I said n can be any real number, right? It can be negative 0.5, it can be positive 0.5, right? Okay, but let's try it. We said if, we said d of dx of x to the power n is equal to n x to the power n minus 1, right? Okay, now let's say we have x to the power minus 5, right? If you compare these two functions, you can conclude from here that your n is now equals minus 5, right? So you know that the derivative of a function like this is equal to n times x to the power n minus 1. Okay, you can come back here where there is n, you substitute n with minus 5. Okay, we have minus 5, so it's minus 5x to the power minus 5 minus 1. And then you simplify this and you have minus 5x to the power minus 6 and leave it like this. Or, I'm not sure whether I should write this. Oh, but then you can write this as 5 over x to the power 6. I didn't want to write this because I didn't want to confuse you guys, but you can leave your answer here. It's still okay. But if you go back to type 8, where they introduced you to the laws of exponent, you can use those laws here and write this like this. But for me, it's fine. You can leave it like this. It's okay. Right? Again, let's say we have minus 10. This means your n is now minus 10. So you come here where there is n, you substitute n with minus 10. So this means you'll have minus 10 x to the power minus 10 minus 1, right? And then you simplify this, you can write this as minus 10 x to the power minus 11 and leave your answer here, it's fine. Did I answer you? Is it fine?
Can I ask you a question?
Ma'am, okay.
Yes, I'm listening.
Why is the powered number not unchanged? Because it's a negative plus a negative. Doesn't a negative plus a negative equals to a positive?
No, that's multiplication.
Oh, okay. All right, no problem. Thank you.
For when you subtract numbers, you take the sign of the bigger number. The sign of the sign of a bigger number. Yes.
Can I ask you a question?
Yes.
With
I'm
this,
listening.
with this power rule, is it possible that the constant becomes the variable, or always the constant? Like if it's like 2 to the power x.
2 to the power x.
Yes. Do we apply?
No, no. That's you use another rule there. That's a different rule.
Okay.
Problem. Okay, can we move on?
Sorry, ma'am, one last question, a quick one. Before we go to the third rule. So let's say maybe is it possible, or is there a possibility of a question? I don't know if this will make sense. So let's say if it's d over dx, right? And then you have x to the power n minus t, for instance. So is that
D
something that
over dx?
yes, and then x to the power n minus t.
Minus t.
Yes.
And you are asked to differentiate this.
Yes, yes.
Okay. We have different derivatives, right? We have ordinary derivatives and we have partial derivative, right? If you are given something like this, let's say you are told that t is a constant, right? So this means you'll treat t as a number. But if you are told that your function depends on x and t, then you are asked to find the derivative of that function. That means in that case, you'll have to use a partial derivative, but it's not covered in this module. So do not worry about it. Here, always, every day, t will be considered as a constant if we are given something like this.
All right, no, thank you so much, Nolwaze.
No problem. Okay, rule 3. This is we'll call this rule the constant multiple rule. I know in your study guide some rules are not given their name. They just, I don't know. But we'll call this the constant multiple rule. I don't know. I won't be asking you which rule did you use. Just make sure you master all the rules. There's no need for you to know which rule is which. Right. Okay. Here, let's say you are given C and you are told that C is a constant and you are given a function f that is differentiable, meaning that you'll be able to find its derivative, right? So, okay, C is a constant and f is differentiable. Okay, then the constant multiple rule says d of dx of c times f of x is the same thing as c times the derivative of f of x, right? Okay, c is a constant, f is a differentiable function, okay? Then the derivative of c times f of x is the same thing as c times the derivative of f of x, meaning you can take c outside of that derivative, that bracket. Yes, okay, let's do an example. Remember, I said we are coming to this rule. Say you are given f at x is equal to 3x to the power 4, right? Okay. This means, okay, we know that 3 is a constant. Okay, so if you have 3 times x to the power 4, you can write this as the derivative of this, of 3x to the power 4. You can write this as 3 times the derivative of x to the power 4. Okay, you take out 3 and then you differentiate x to the power 4. Okay, we do not leave it here. You see, now it's in a form of a power rule. We can then use the power rule here. And then you can have 3 times, okay, if you compare this to the power rule, you can conclude from here that your n is 4. So if we use the power rule here, we'll have 4x to the power 4 minus 1. And then you simplify further. This would be 3 times 4x to the power 3. Again, another step, we simplify. This would be 12x to the power 3. Okay. Again, let's do another example. Suppose you are given y is equal to minus x, and you are asked to find the derivative of this function. Okay, remember, for power rule, we have something like this. Y is equal to x to the power n, not minus x, not minus a function. Okay, now we have minus x, meaning we can write this function as y equals minus 1 times x, so that here we can use the power rule. Okay, if we write this function like this, right, this means we now have c, which is a constant, as minus 1. Okay, we go back here. We said you can take out the constant and then multiply the remaining function. Okay, so this means our d of minus x dx is the same thing as minus 1 d of dx of x, right? Because we are now differentiating x. Now we can apply the power rule here. Okay, if you compare this to this, you can conclude from here that your n is equal to 1. Right, so this means we will have minus 1 times the derivative of this. Your n is 1, so it's 1 times x to the power 1 minus 1. Remember, we have to subtract 1 from the power. Okay, simplify this. You'll have minus 1 times 1 times 1 minus 1. This is 0. Okay, then we go back to grade 8 again. We are using grade 8 today. Rules, power rules. Any number, okay, besides 0, any number raised to the power 0 is equal to 1. So this is 1. So instead of writing x to the power 0, can substitute that with 1. So this means,
Wait, sorry, ma'am. Can you please repeat that rule?
any number raised to the power 0, okay, besides 0, then that number is equal to 1. Any number raised to the power 0 is equal to 1 besides 0. So this means if you have 5 to the power 0, this is the same thing as 1. 100 to the power 0 is the same thing as 1. 50 to the power 0 is the same thing as 1. So whenever you see a number or a variable to the power 0, just write 1 there. Is it fine? Okay, so we have 1 minus 1 times 1 is 1. Yes?
Is it a necessity for me to show all the steps?
No, remember we are writing a multiple choice. So you need
Okay,
to
I mean
know
on the
how to
exam
get to
though.
the correct. You still writing a multiple choice.
All right.
I'm just showing
So
you how
in the
to get
exam,
to the correct answer.
so even in the exam, it's still multiple choice.
Yes, it's a multiple choice. You guys are too many, so that's why we have a multiple choice in this module. You are more than 3,000. I won't be able to mark all those papers, the streets. So it's a multiple choice.
So now it means whenever, because our exam is online, we'll be writing our working outs on a paper and then select the correct answer on the system.
Yes. Like how we are doing in the on the assignments, the exam will be the same thing.
Well, okay. Thank you.
Oh, okay. No problem. I'm not saying you guys you should copy and then you ask someone to write questions, to calculate question 1, then you calculate question 2, because we won't be able to see that you guys are writing together and then you select the answers.
Ma'am?
Change the question paper. We have 3 question papers. So if let's say you are writing together, maybe you are 3, chances are your question 1 won't be the same as the question 1 for student B, but then it's fine. Do you have a question?
Before you continue, why you got negative
Yes,
1?
ma'am.
I'm lost.
-1.
Yes.
We had -1 here. Remember, our function was minus x, and for us to use the power rule, we said we use a power rule if you are given x to the power, as in a positive x, right? Then I said we can write this minus x as minus 1 times x, right?
Okay.
Then we took out minus 1, then we differentiated this x. Now we are applying the constant multiple rule. Then that's why we have minus 1, because we kept them going down with this. Yes?
Okay, the equation is x to the power n, not minus 1.
Yes, it's x to the power n.
Okay, thank you.
Then the derivative by prime would be n x to the power n minus 1.
Okay.
That's why we have this minus 1. No problem. Can we move on to another rule? Rule 4. Do we have questions?
Yes, ma'am. Or
Yes.
in the exam, can we use our books?
Yes, it's an open book. As long as you are not writing with someone else, there's no one helping you. You can use your book, you can use Google, you can use the apps that you guys use. It's fine as long as there's no one helping you. Because with in this module, it's the same thing with assignment 5. We use Moodle Plottering, which is just the Moodle tool that keeps on taking the pictures of you, right?
Yes.
So you have to make sure that the camera is on, then it keeps on taking the pictures of you. I know sometimes you'll be facing down, calculating, having papers everywhere. It's fine as long as I see that it's just you alone, there's no one else.
Okay.
Wait, ma'am, hold on. I just
Hold
want to
on,
get
sorry,
this
ma'am.
right, ne?
Yes.
I just want to get this right. So this exam is open book.
Yes.
It's open book, ne?
Yes.
Okay, because hey, this is strange. A math exam, it's open book. Hey, this is the first time I'm hearing this.
The thing is, even if I tell you guys that is not an open book, you're still going to use you're still going to be using your books. So yeah, why would I restrict it?
Okay, I just want to ask, ne? I also just want to ask regarding the camera. How do I get it? Do I download it as a software, or what do we do?
No, you have to make sure you use a device with the camera. Another thing, if some people close their camera, like they put something on their screen to cover their camera. If your screen is blank, then we do not release your marks. We send you for disciplinary hearing, and that could delays you to continue with other semesters because you have to wait until you attend the disciplinary hearing. Like right now, we're still like those students who I sent for disciplinary hearing last year, first semester and second semester, they haven't attended the disciplinary hearing. You see, now they are wasting this year too because they can't continue with their studies while there's a disciplinary pending. So just make sure your camera is on. Do not cover it.
Okay, like I don't understand.
Like,
When you say
you
camera,
can use your book.
can I ask
You
when
see on
when
your
you say
phone, on your phone there's a camera. You can use your phone to write because you like the multi-plottering will be able to take pictures of you from your camera. Right? You can use your laptop with the camera to write because the MOOC will be able to take the pictures of you. If you are using a device with no camera, you won't be able to access that exam. You'll notice with assignment 5, it says multi-proctoring, meaning your camera must be on so that it will keep on taking the pictures of you.
Okay, so will it tell me to turn on the camera, or must I find it? I am really confused here. Eh?
Can I just come in and try to assist me? So what happens is when you go to your exam, you won't be able to access any questions unless your camera is on. So it doesn't matter whether you will try to hide, as long as the camera cannot see your face, then you cannot access the questions.
No, I understand that part, ne, but the camera, where do I where do I go?
There is
Like,
a
let's say
pop-up that says
You don't have to install or download anything. As long as your phone or your laptop has a camera, then you'll be able to write. Because the tool is installed there on my exam on MOOC already. You don't have to install anything. Just make sure that your device has a camera and your settings are fine. Then you'll be able to write.
Oh, okay.
Ma'am,
You are
sorry,
not downloading anything. I know in some module they are using this app that you need to download.
Invigilator app. And
app.
Yeah, that's what I also know. I'm saying that's what I also know. They're also using Invigilator apps for some of them.
Your tutorial.
Ma'am, can I please
we are not
come
using
in there?
all those apps. We are using multi-plottering. If it change, if they say we have to use a different one, I'll let you know. But for now, we've been using. Yes.
Ma'am, are we provided with formulas?
Yeah, I'm listening.
Are we provided with the formulas?
Did I mute myself? Can you guys hear me?
Yes. Yes, can you?
Yes.
Yeah, we can.
I was asking, are we provided with
Is that my network or yours?
Can we just continue with that? Is it a fourth rule so that we're going to discuss that one later, guys?
I said you guys you can use the standard guide, your study guide. So there's no need for me to give you formulas because you'll have your study guide open.
on the exam when we're
Hello, ma'am.
writing the exam?
You'll have your study guide, you have notes.
Sorry, ma'am, can we have order? Can we please have order?
Yeah, that was so bossy. Okay, let's
I'm
continue.
sorry because I'm trying to say something. I hear there's a gentleman who is mentioning a very important point there. And then with asking a lot of questions, I think we are wasting a lot of time to finish with what it has been put to place. Can we continue? Then, ma'am, can you please inform us on the group as to how do we go about writing an exam and other things, please?
You write assignment 5. For assignment 5, I made the settings in such a way that they will prepare you for the exam. You only need a camera. That's the only thing you need compared to the assignments that you are doing right now. And it's timed. And okay, for assignment 5, you are given two attempts. For an exam, you are given 1 attempt. And again, you can move to the next question and leave the current question and come back to it again. You'll be able to do that. But I'll send you the rules before the exam.
Ma'am, will the exam be timed?
Yes, the exam is timed. Yeah.
Hello.
The exam is timed. Can we move on to rule 4? We'll discuss the exam before the.
Before you move on to rule 4, ma'am, can I just ask, is it possible to do as well the math background? I see that there's a very important section. It's a foundation upon which the module is building on. Is it possible to do because there's a lot of material there? Is it possible to go through the entire maths background simultaneously same time as doing the entire module? Because I think there's a lot of material there covered, and it's important for all the what you call the study units that we're going through. But is it possible to do them at the same time to maybe to go through the math background and also go through each and every study unit? Or should we do the math background first before we continue to all the what you call it the study units?
That section wasn't part of my section. Those simultaneous solving equations were part of the previous sections.
Oh, I'm talking about the you know I forgot which annexure is it. There by the back of the study guide. There's the math background. I forgot which annexure is it. It goes through I think the foundations of the mathematical background that the entire module is building up on. I was referring to that. Is that the back? I think section 9 or I forgot what is it, section 9 or something. That's the one that I was referring.
I've never even opened the study guide, to be honest with you.
Oh, okay.
Can I answer that?
Yes.
Yes.
We have the tutors.
Right. So I think that's personal. If you don't understand other things, then you can always go back to the back of the study guide and try to get the foundation and the basics before you can continue with the rest of the content.
Oh, okay.
Also, guys, there's a tutorial letter that explains almost everything.
And there are tutors that you can ask questions, and you can send me an email if you don't understand something. But do not send me questions. Nah, I don't respond to how's exercise, how do you do this exercise? No, you have to attempt that exercise, then I check your workings and see where you went wrong, then I explain.
Okay. Can we move on?
Okay, rule 4. We don't even have time. The sum rule. Okay, if you are given 2 functions, f and g, and those functions are both differentiable, right? And let's say you are asked to find the sum of those functions. Like you are asked to find the derivative of f at x plus g at x, right? You can write the derivative of this function as the derivative of f at x plus the derivative of g at x. You can separate them. Okay, that is the sum rule. For example, say we have y equals x to the power 8 plus x to the power 4, and you are asked to find the derivative of this function of x to the power 8 plus x to the power 4. Okay, you can write this as d over dx of x to the power 8 plus d over dx of x to the power 4, right? And then, here you can use your power rule, and also here you can use your power rule. If you use your power rule here and here, you should get 8x to the power 7 plus 3x to the power 4. Okay, that is the
Ma'am, is
Yes,
it
ma'am.
supposed to be 4x?
4x to the power 3.
4x to
Yeah.
the power 3?
X to the power 3. Yes. Oh, thank you. I just
Sorry,
wanted
ma'am.
to know if you guys are following. Yes, I'm listening.
Sorry, ma'am. Isn't it supposed to be 4x to the power 3?
It is 4x to the power 3. Okay, I'm glad you guys are still with me. 8x to the power 7 plus 4x to the power 3. Okay. Do we have any more questions? Rule 5.
Wait, sorry, ma'am, can you just go a little bit up? I just want to just write that down again.
What are you writing down?
I just want to write down the answers, the equation again, just for a little bit.
Yes. You'll get the recording.
Okay.
Okay, we do not have enough time remaining. All right. Rule 5. I'll call this the difference rule. The difference rule. Okay. If you have two functions f and g and they're both differentiable, then the derivative of the difference of these two functions, let's say df minus dx, right? You can, okay, the derivative of this function is the same thing as the derivative of f at x minus the derivative of g at x. Okay, let's do an example here. Again, say we have y is equal to a to the power x minus x to the power 4. And we are asked to find the derivative of this function. Okay, d of dx of x to the power 8 minus x to the power 4, right? You can write this as d of dx x to the power 8 minus d of dx x to the power 4, right? You do this the derivative of this separately and the derivative of this, and then you subtract them, find the difference. Okay, the derivative of this, we said it's 8 x to the power 7 minus the derivative of x to the power 4. It's 4x to the power 3. And then you can leave your answer here. Do we have a question?
Hello, yes, ma'am, I have a question.
Yes.
So is there a step where you just keep it because of whereby you said 8 minus 1 and also 4 minus 3 to get the exponent 7 and the exponent 3?
There is no need to write the step because you're writing a multiple choice, right? I need the final answer. And Okay, the reason I'm not doing it, I am just
that's what
assuming you know now how to use the power rule.
Oh, okay.
Because we've been doing the power rule ever since we started. So I'm just assuming you know how to do it now. That's why I'm just giving you the final answer. And another thing, we don't have much time remaining. And I wanted to combine all these rules that we've been doing so far before we go.
Sorry, Miss.
Yes.
So the only
I'm
difference
listening.
between rule number 4 and 5, it's the sign. Because I've noticed that rule number 4, it's positive, and rule
Is it
number
my
5.
network or has?
We can hear you, ma'am.
Hello.
Yes, it's the sign.
Okay, thank you.
Yes, it's the sign. Okay. Yes, the only difference is the sign. The other one. All right. The other one, you're finding the difference. The other one, you're finding the sum. Okay, let's try and do the example where we'll have to apply all the rules, all the 5 rules that we've been doing. Okay, suppose you are asked to find the derivative of this function, y equals x to the power 8 plus 12 x to the power 5 minus 4 x to the power 4 plus 10 x to the power 3 minus 6x plus 5. Okay, say you are given a function like this, you are asked to find its derivative. Okay, first I will apply the rule 5, rule 4, and rule 3 all together same time. Okay, meaning I will separate this function, right, with their signs, and then I will take out the constant, the one that is multiplying the 10. Okay, meaning we have y prime equals d of dx of x to the power 8, right? Plus we take out the constant, that's rule 3. So 12d of dx of x to the power 5. Okay, we take out minus 4. Minus 4d of dx to the power 4, right? Plus 10d dx of x to the power 3 minus 6d of dx times x plus d of dx of 5. Okay. Here, you see, you can apply the power rule. We can apply power rule, power rule, power rule. Again, power rule. Then the derivative of a constant. Okay, if we apply power rule here, we'll have 8x to the power 8 minus 1. Again here, 12 times 5 to the power, okay, times x to the power 5 minus 1. Here, minus 4 times 4x to the power 4 minus 1. Here, plus 10, 3x to the power 3 minus 1 minus 6 times x to the power 1 minus 1. Okay, the derivative of a constant. So You can write, or can you leave it like that and do not write it, right? Okay, then we simplify. If we simplify, we have this. This will give us 8x to the power 7, right? And then plus 12 times 5x to the power 4 minus 4 times 4x cubed. Plus 10 times 3 x squared. Let's see from here. Then we have this minus 6 times x to the power 0. There is no need for us to write this plus 0. Again, you simplify further. We have this term, and we have 12 times 5, that's 60. So plus 60 x to the power 4. We have minus 4 times 4, minus 16 x to the power 3. 3 times 10 plus 30 x squared. We said this is the same thing as 1. So we have minus 6 times 1. That gives us minus 6. And you can leave your answer like this. It's fine. Do we have questions before? I don't know. We move on or we leave? Yes? No?
Ma'am, I just wanted to ask.
Yes.
Okay, you see, where you started separating sharp, ne? The last one you said, plus d over d of x times 5, ne? And then
yes.
in the second, in the following line, you said, is it plus 0 at the end?
Yes, it's plus 0 because we said, you remember rule 1 says the derivative of a constant is 0.
Oh,
right?
okay.
Yeah, and 5 is a constant, so the derivative of 5 is 0.
Thank you.
Your own spare time, please try this.
Can I ask, ma'am?
Yes.
At the end, do we have minus 6x or it's minus 6?
Minus 6. Remember, this is just 1. So if we substitute this with 1, we'll have minus 6 times 1, which is minus 6. Was
Okay,
it
ma'am,
fine?
can I just confirm?
Yes.
Hello.
I'm
So we
listening.
used only rule 3, 4, and 5, right?
We used
Rule
all
3.
the rules.
Yo.
We
Okay.
used all the rules because you see here we have addition. We have this function plus this function, right? And we said the one that separates this, if there is plus, is rule 5, right? Okay. You have minus here. The one that has a minus, it's rule 4. Okay. You have a constant. The one that where you are asked to find the derivative of a constant is 1, right? And then we apply the power rule. When we apply the power rule is rule 2. And then we have a constant times a function where we take out the constant, that's rule 2. So you see, we've applied all the 5 rules in one function.
So the minus 4x to exponent 4, what function is that?
Which one? Minus 4
The
x to the
minus.
power. Okay, where you took out this minus 4, where you took out this minus 4, you were applying rule 3. Remember, rule 3 says if you rule 3.
Yes. Got that.
You have a constant times a function, right? You have a constant times a function. You take out the constant before you multiply, before you find the derivative of this function. That's rule 3. So that's what we applied there. Here. Even here, we did apply that rule, and here, and here. Okay, in your spare time, please try this.
Ma'am, number 2, is it an S or is it a 5?
Yeah.
Hello?
It's
an S.
This is S. Yes,
Okay,
but this is
thank you.
5. It's like where there is Y, I substituted Y with S. And then where there is X, I substituted X with T. It still apply the same rules. It's just that here you will have X prime, or you'll have F of T, because you are differentiating this function with respect to T. So guys, you do have 10 minutes, right? Okay, just 10 minutes, not even 10 minutes, even 5 minutes to do one more rule. Okay, then I'll leave the rest to
No problem.
the next session.
Yes.
Thank you. Ngiyabonga. Okay, rule 6. This is just the derivative of a natural exponent function, right? Says d over dx of dx is e to the power x, right? Then for a natural log, dx of natural log is 1 over x. Okay, if we are differentiating e to the power x, you will get that e to the power x. But okay, I forgot to put x here. But if you are differentiating ln x, you'll have 1 over x. Okay, say we are given y equals ex plus ln x, and we are asked to find y prime. Okay, this would be dx plus dx of ln x, right? And we know that here, yes.
So sorry, ma'am. Can you go back to when you explain the rule? Start there. I think I lost you somewhere. Just at just start at the beginning, please.
Okay, if you are asked to find the derivative of e to the power x exponent, like that is a natural exponential function, e to the power x. The derivative of this is the same as this function, right? So if you are asked to find the derivative of e to the power x, that you'll find e to the power x. And if you are asked to find the derivative of ln x, it would be 1 over x. It's just the rule.
Okay, I got it. Thanks.
All right, no problem. Okay, then if you are given y equals e to the power x ln x, and you are asked to find the derivative of this function, then your derivative would be the derivative of this plus the derivative of this. Remember, we separate these using rule 5, which is the sum rule or the addition rule. Okay, let's say we are given a function like this. Y equals e to the power 4 minus 3x squared plus e to the power x plus ln x, right? And we are asked to find the derivative of this function, y prime. First, we separate everything. So d over dx of x to the power 4, d dx of x squared plus d over dx of e to the power x plus d over dx of ln x, right? Okay. Here you apply the power rule and you'll obtain 4x cubed minus 3 times you apply the power rule, you obtain 2x, right? Here we said the derivative of this function is this function, so we have plus e to the power x. The derivative of this function is 1 over x plus 1 over x. Okay. I will leave it here, okay? We still going to find the derivative of a function like this. Y equals e to the power, maybe a constant x. And we're still going to find a derivative of a function like this. Y equals ln maybe x squared. Because you apply the different rule here and here. We're still going to do another rule that will help us find the derivative of this and this. So do not apply the rule 6 here and here. Because here we have cx, yes, and here we have.
Where are these rules on the study guide? I'm trying to find them.
On study guide.
Can someone just direct me where to find these rules?
On the differentiation theory.
From
Chapter
page
7, you can
On
see
page
chapter 7.
59. Page 59.
Page 59.
Chapter 5.
From 7.
Okay, with the study guide, I know some rules that you are given them. They didn't example. They didn't tell you the name of that rule. They just
Yes. Yeah, that's what I'm saying. I wanted to see like this rule 1, rule 2, but I'm just saying the names, like the power rule of differentiation, and then a lot of examples, and then again, like I'm kind of lost. And I see you have 6 rules here.
I was just doing my own summary. But the study guide is still correct. It's just that it didn't name other rules.
Rule 6 is on page 16.
Okay, cool.
Sorry, page what?
Page 60.
Oh, okay, thank you.
Wait.
And you notice that they wrote an example for this, but these you apply another rule here and also here.
How do you know it's rule 6 on page 60?
I'm not sure it's page what.
The person said page 60. The power, I'm saying the power rule of 4 differentiation.
In the study guide, there's only 5 rules.
Hmm?
In the study guide, there's only 5 rules.
Oh, you're seeing 5. So the gray shaded formulas, those are the rules of what's happening. So I'm seeing a lot of examples here.
Yes, those are the rules.
Those are the rules, no?
The gray shaded, yeah.
Yeah. Okay. So I should just go with
No,
the
I
other.
also did them. Thank you, guys. All right.
Okay, all right then. even though they're not written, rule 1, rule 2, but I'll just go with the order.
Oh, I see now. Okay, there's 6.
Okay, thank you, guys.
Okay, in your spare time, please try these two again. Okay, I think we are left with the product rule, the quotient rule. Okay, yeah, those two, the product rule and the quotient rule.
Yeah.
Oh, plus the chain rule.
The chain rule. Xikwembu xa mina xa matimba.
Okay, today, this is what we did. The derivative of a constant, right? We said it's 0. And the derivative of x to the power n, we said it's n x to the power n minus 1. I'm just doing a summary here. There is no need. Then we said a derivative of e to the power x is equal to dx. All right. Then we said the derivative of a constant. Okay, let me write this as the derivative of the constant is equal to the constant times the derivative, right? And then the derivative of f plus g. Okay, this represents the derivative. Remember, the derivative of this would be the derivative of f plus the derivative of g. Then we have the derivative of f minus g. It would be the derivative of f minus the derivative of g. Right? Then, yeah, this the summary of what we did today, what we've covered in today's section. 1, 2, 3, 4, 5, 6. Do we have questions?
Ma'am,
Yes,
could you
yes.
just lower it down?
Yeah, I just want to ask Ne to just double check this video, Ne. Are you gonna send it on my announcements in my UNISA, or are you gonna use it on Teams? Because on Teams, it's a problem for us to access this because we don't know where to even find it. Hello?
Okay, tomorrow. Yeah, I'm still here. We
Yes.
have a YouTube channel in this module, right? Okay. If you go to YouTube and search DSC1520, that's where I post the videos. Then I take the link of that video, I upload it under the lesson, right?
Under the
If
lesson, what do you mean? Like in my UNISA, Ne?
Yes, on Moodle, we have different lessons. Let's say we have lesson 1 up to 8.
Differentiation.
Let's say this is lesson 8, right? Then I will go to lesson 8 and upload them and put the link there to the YouTube channel.
Okay.
So you just have to know the dates and know which lesson is this.
Oh, okay.
Because they are too big. It's not easy for me to upload them on Moodle. Sometimes it takes forever. So I prefer to download them here and put them on YouTube, and then it stays there on YouTube. Because sometimes here they expire. I don't know, they take for how long. And some people prefer to use previous classes recording, so and on YouTube they stay forever. So that's why I prefer to put them there.
Okay, so let's say if I go on YouTube now, Ne, do I type DSC1520 2024? Is that where I'll find you?
No, just say DSC1520. You'll find all the videos for previous classes that I did for previous
Oh,
classes.
Okay, so the previous classes, is it what we were also discussing now, or is it?
Mm. Even this part, it's there. There is a video on this part where I was teaching this session, and for another session, the following session, the previous session, because Prof. Mabemadise only took over last year in September when I went for leave. So she only started teaching then, but before then I was teaching. So
you're back full time now, no?
Ma'am, thank you.
Ma'am, can you please share your
Slides.
screen because I wasn't able to get the previous equation. I only just got the first one. Can you please share just so I can see that second function?
yeah, that's part or the try.
The
This
try,
one.
please.
The try, just the last one that we were doing now before you did the summary.
It's
the
this
try.
one.
I can't see, ma'am.
Okay. I'm not sharing.
It's not sharing yet.
Okay, is it
Maybe
fine
it's
now?
gonna pop up in the
Coming just now.
recordings.
There we go. Thank you so
okay.
much. There we go. Thank you.
So there's someone only joining right now. You guys are not serious.
Thank you for using Word instead of the slides.
Yo,
They're very
thank you.
convenient.
Thank you, Ms. Nkomo. Yo. And I hope we stay here for
Khomela manje ngisane class live laptop online.
Hello, ma'am.
Yes.
Maybe that person had network problems, guys. Who knows?
I hope she doesn't come back.
Hayi bo, utheni masukumsa.
Ms. Nkomo is okay. That's recorded, guys. That's recorded. Don't say a lot of things.
Ms. Ngoma, I have a question, please.
Yes.
Earlier on, you mentioned that when you were mentioning about the exam being open book, you said we could use Google and all of that. So I want to ask when that Moodle app is open, are you allowed to close it and use Google, or it needs to be open at all times? And if it needs to be open at all times, are you allowed an additional device to access Google? How does it work?
You can open multiple screens, right? As long as you do not open the exam in different streams, because some people they write for each other. So like you'll join and then someone join for you again, then it locks you out, right? But if in one laptop you open different browsers, it's allowed, unless they've improved their system this semester. But in previous semesters, you were allowed to open different browsers. So you can open another one on different browsers.
Thank you.
No problem.
Hi.
She's good. Yeah.
Can you at least give us the previous lessons if it's possible?
It's on YouTube. Previous last week's session.
She said she can open most last week's sessions from the
But
previous
last year's ones are uploaded from
on YouTube.
From last year.
But the previous lecturer, she didn't do the right thing when she recorded. Hence, Ms. Nkomo couldn't open. But I think YouTube will have all the previous lessons of the previous.
The previous lecture was way off schedule. I'm not gonna lie, guys.
Way of schedule.
Just way of schedule.
Was only reading.
Guys, yo.
Slides.
I fell asleep. Like honestly, nah, yo.
And she was too
Yo,
fast. Yeah.
are you guys repeating?
She was too fast.
It was the problem.
No, you should read that book.
Hi, everyone.
Hi everyone.
She had an idea of a study guide, how it looks like, what is there, what is not there.
We're trying to reason with her until we
Yeah,
don't
man, I
understand.
really
She's fighting with everybody.
Please stop the recording, Mrs. Kunkuma, because a
Stop
lot
the
of
recording,
things
Mrs. Goma. Hey,
is on YouTube also. I already
disciplinary.
saw it.
Bye, everyone. Thank
But
you.
some students
Bye
repeating.
everyone. Thank you.
Bye-bye.
Bye.
Bye-bye.
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 Thank you.
Bye.
Bye.
Hey.
And good luck.
Slow in when I'm man.
Okay, I see 3 hands. Are they all hands? Yes. Okay, if we don't have questions, I think we can end here. Thank you so much, guys, for your time. We'll meet on our next session. Thank you. Bye.
Which is Wednesday, right, ma'am?
Maya bouncing. Papuleto Robert Kakulungat. Hey. Eh. Yes, kuzokhipha. Ufake epleyitini gogo ngizoyikhipha mina fake esikhathini. Ngithi fake epleyitini.